Good morning, students. Today we will discuss the topic power series solutions. Now, for this, the solution of ordinary linear differential equations of second order with variable coefficients in the form of an infinite convergent series is called solution in series or integration in series. Now, before we start, let us discuss some definitions. First is power series. An infinite series of the form summation n varying from 0 to infinity a n x minus x naught power n, that is a0 x minus x naught power 0 plus a1 x minus x naught power 1 plus a2 x minus x naught whole square. This is called a power series in ascending powers of x minus x naught. Now, in particular, if x naught is 0, then for x naught equal to 0, the series becomes summation n varying from 0 to infinity a n x power n. This will be a naught plus a1x plus a2x square plus a3x cube, so on. This will be called a power series in ascending powers of x. For example, if you have e power x, then its expansion is 1 plus x square by 2 factorial plus x cube by 3 factorial, so on. Or it can be written as summation n varying from 0 to infinity x power n over n factorial. This is also power series in x. Now, analytic function. A function fx defined on the interval containing the point x equal to x naught is called analytic at x naught if its Taylor series sigma n varying from 0 to infinity nth order derivative of fx at x naught divided by n factorial x minus x naught power n exists and converges to fx for all x in the interval of Taylor series. Or you can remember the previous definition which we had done, that an analytic function is that function which is differentiable at that point, in simple way. You can remember the previous definition. Now next is ordinary point. We have three types of points: ordinary point, regular point, regular singular point, and irregular singular point. These 3 points: ordinary point, regular singular point, and irregular singular point. Now suppose that we have the differential equation d2y over dx2 plus px into dy over dx plus qx into y equal to 0. Then the point x equal to x naught is called an ordinary point, of 1 if both of the functions px and qx are analytic at x equal to x0. If both of px and qx are analytic at x equal to x0, then this point will be called ordinary point of differential equation 1. Next one is regular singular point. Now if x equal to x naught is not an ordinary point of 1, then it will be called a singular point. Then it is called a singular point. Now under this we have two definitions. Now, and if x minus x naught into px and x minus x naught whole square into qx, these are analytic at x equal to x0, then x equal to x0 is called regular singular point, of 1. Otherwise this point is called irregular singular point of 1. Now if x equal to x0 is not an ordinary point, and not a regular singular point, then it is called an irregular singular point. For ordinary point, both of px and qx should be analytic at x equal to x0. Now if the point is not an ordinary point, then we have 2 points, regular singular point or irregular singular point. For regular singular point, the functions x minus x0 into px and x minus x0 whole square into qx, both of these become analytic at x equal to x0. Otherwise the point is called irregular singular point. Now we will discuss the solution for ordinary point and number 2 for regular singular point. The solution of the differential equation 1 at irregular singular point, it is beyond the syllabus. So we will discuss only these two solutions. Now for this, if x equal to x0 is an ordinary point, of 1, then every solution of 1 can be written in series, as a series of the form y equal to a0 plus a1x plus a2x square, so on. And if x equal to x0 is a regular singular point of 1, then at least one of its solutions can be written as y equal to a0 x power m plus a1 x power m plus 1 plus a2 x power m plus 2, so on. Now you have to remember that for the ordinary points you will take this solution, and if the point is regular singular point, then you will take this solution and then proceed. Now today we will discuss the solution for an ordinary point. Now I directly start with the question. Solve in series the differential equation d2y over dx2 plus xy equal to 0. Now I compare 1 with d2y over dx2 plus px into dy over dx plus qx into y equal to 0. We get px equal to 0 and qx equal to x. Both of these are polynomials. Therefore, at x equal to 0, both of px and qx are analytic functions, and therefore x equal to 0 is ordinary point of 1. Therefore we will assume the solution as, therefore let the solution of 1 be y equal to a0 plus a1x plus a2x square plus a3x cube plus a power 4x power 4 up to an x power n, so on. Now from here I will find dy over dx and d2y over dx2 and then substitute these values in 1. Therefore dy over dx, its derivative 0, derivative of x is 1, therefore from here I will get a1, its derivative 2a2x 3a3 x square 4a4 x cube. If I wish to write next term, that will be 5a5 x4 6a6 x5 plus up to n x power n minus 1, so on. And d2y over dx2, it will be derivative of a1 is 0. Now one thing you have to remember, that I will equate the corresponding the coefficients of corresponding terms, and I will also equate the coefficient of x power n. That here I will take again it's the next term n plus 1 an plus 1 x power n, and next term will be n plus 2 a n plus 2 x power n plus 1, so that I can get the term containing x power n. Now d2y over dx2, derivative of a1 is 0. From here 2a2, 3 2 is 6, or 3 into 2 a3x, next will be 4 into 3 a4x square, 5 into 4 a5x cube, 6 into 5 a6 x power 4, its derivative n minus 1, n into n minus 1 an x power n minus 2, n plus 1 n plus 1 x power n minus 1 plus n plus 2 n plus 1 an plus 2 x power 1 reduced, that is n plus 1. Now substitute these values in 1. Put these values in 1. We get, first is d2y over dx2. d2y over dx2, this whole 2a2 plus 3 into 2 a3x, 4 into 3 a4x square, 5 into 4 a5x cube, 6 into 5 a6 x power 4 up to nth power n plus 2 into n plus 1 an plus 2 x power n, so on, plus. Now here dy over dx is missing, I will not use this value. X plus x into y, y is a naught plus a1x plus a2x square plus a3x cube plus a4 x power 4 plus, now as I will equate the coefficient of x power n, here I have 1x outside, here I will write one more term n minus 1 x power n minus 1, next will be n x power n equal to 0. Now equate to 0 the coefficients of various powers of x. First of all, I will equate to 0 the coefficient of constant term. Constant term. Now in here the constant term is 2a2 and here no constant term, equal to 0. This implies a2 equal to 0. Next, coefficient of x power 1. Here 3 into 2 a3 and here plus a0 equal to 0, or this implies a3 is minus a0 over 3 into 2 I can write into 1, or this implies a3 is minus a0 upon 3 factorial. Now I have to explain what is factorial. First, if you have 0, 0 can be written as 1 factorial. 1, it can be written as 1 factorial. If 2 into 1, it is 2 factorial. 3 into 2 into 1, this is 3 factorial. 4, 3, 2, 1, that is 4 factorial. Suppose you have to evaluate 10 factorial. This will be 10 into 9 into 8 into 7, 6, 5, 4, 3, 2, 1. That means if you have to evaluate 10 factorial, then you will multiply all the terms up to 1 starting from 10. Now coefficient of x square. Coefficient of x square. X square. Here it is 4 into 3 a4, and here when you will multiply a1 x with x, you will get a1 x square, that is plus a1 equal to 0, or this implies that a4 is minus a1 over 4 into 3, or it can be written as minus 2a1 over 4, 3, 2, 1, that is a4 is minus 2a1 over 4 factorial. Next, coefficient of x cube. Coefficient of x cube. Here it is 5 into 4 into a5, and here coefficient of x cube, and this will be multiplied with this, that is plus a2, or this implies a5 is minus a2 over 5 into 4, and a2 is 0, or this implies a5 is 0. Next, we will equate coefficient of x power 4. Now coefficient of x power 4. Here it is 6 into 5 into a6. 6 into 5 into a6, and in the next equation it is coefficient of x4 a3 plus a3 equal to 0, or this implies that a6 equal to minus a3 over 6 into 5. Now substitute the value of a3, that is a3 is minus will give you plus a0, 6 into 5 into 3 factorial, that is a6 is a0, 6, 5, 3, 2, 1. 4 is missing. Here I multiply it with 4, that is a6 is 4 a0 over 6 factorial. Now I will equate coefficient of x power n. Coefficient of x power n. Here it is n plus 2 into n plus 1 an plus 2, and here when this multiplied by x, that is 1, here it is an minus 1, not n minus 1, plus an minus 1 equal to 0. Or this will give you an plus 2 equal to minus an minus 1 over n plus 2 n plus 1. Now to find the remaining coefficients, you can substitute remaining values of n in this equation. Call it number 2. Now we have calculated up to a6, a2, a3, a4, a5, a6. Now put n equal to 5 plus 2 will be 6, n equal to 5, 6, 7 into, you will get a7 equal to minus a4, 5 plus 2 7, 5 plus 1 6, that is equal to, now a4 is minus 2a1 over 4 factorial, minus minus plus 2a1 over 7 6 4 factorial. Now here 5 is missing, 7 6 5 4 3 2 1. This will give you 10a1 over 7 factorial. a8 will be obtained when you put n equal to 6 minus a7, 6 minus 1 5, a5, 6 plus 2 8, 6 plus 1 7, and a5 is 0. This implies a8 is 0. Next a9, that means n equal to 7, minus a7 minus 1 6, 7 plus 2 9, 7 plus 1 8, and a6 is 4a0. This will give you minus 4a0 over 9 8 6 factorial. Now here 7 is missing, minus 28 a0 over 9 factorial, and so on. Now substitute all these values in this assumed solution here. Therefore solution is, therefore solution of 1 is y equal to a0 plus a1x plus a2x square, a3x cube, a4x power 4, a5x power 5, a6x power 6, a7x power 7, a8x power 8, a9x power 9, so on. Now we will substitute various values. Now a0 is a0, value of a1 is also not got, a2 was 0, a3, value of a3 was minus a0 over 3 factorial, minus a0 over 3 factorial x cube, value of a4 minus 2a1 over 4 factorial x power 4, a5 0, a6 4 a0 over 6 factorial x power 6, a7 was plus 10 a1 over 7 factorial x power 7, a8 it was 0, a9 minus 28 a0 over 9 factorial x power 9 plus so, or it can be written as, now I will separate these, in which there is a0 1 minus x cube over 3 factorial plus this term 4 over 6 factorial x power 6 minus 28 over 9 factorial x power 9. Then a1 plus a1 x, or take x inside x, now its term minus 2 over 4 factorial x power 4. Then this plus 10 a1 outside 10 over 7 factorial x power 7 plus so. This is the required result. And like this you can solve every differential equation of second order, ordinary differential equation of second order, which has an ordinary solution, an ordinary point. Now in the next lecture we will discuss the differential equations with regular singular point. Thanks.